direction of friction will be towards left. Now, this friction, what it does, it will retard center of mass and it will set up anti-torque or clockwise torque. And because of that, the angular velocity of this will decrease. Let's check one by one. So this will be velocity V1. I need more diagrams. No. So what will happen to this? First, no. Let me put, please do make observation. The velocity of point P, I'll come and check it. So because of this, the angular velocity decreases. The velocity of point P, I'll come and check it. It'll be towards right. Still it will be. And the friction will be acting backward. So what is this? Still forward. Slipping, I'll write in short Fs. Now also it is forward slipping. V1 greater than R omega 1. Now at one instant, it is such that the friction weapon will be setting up anti-torque, and because of that weapon, only it will have linear velocity. Angular velocity will become 0. Call this is V2. Still you have to call this a forward slipping. Then now the friction will act backward. This friction acting now, what it does, it will increase the, decrease the linear velocity, will increase the angular velocity. Again, I'll check it. I'll see that here, the velocity of point P, again, it will be non-zero. And I'll check it. It will be forward slipping. Now, continuously, if it continuously acts at one instant, it will have pure rolling. A very first question you have to ask, sir, how the hell you are telling all these things? What is the basis? I can assume another way. Definitely no. On what basis you are writing drawing diagrams and writing this friction, forward slipping, and finally say pure rolling? How do I, as a student, come to know this? There should be some method, some systematic approach. Since you are teaching for past 18 years, okay, you are writing it, but you are asking us, you are forcing student to memorize, or shall we remember? It will happen like this only. No need to remember anything. There's no necessity to forcibly accept anything. Just take help of this one. What is the initial angular momentum? Come for initial angular momentum. I just shown the sequence. Let me apply initial angular momentum. Let's calculate here. Initial angular momentum due to translatory motion of center of mass plus rotating motion about center of mass of the rigid body. Due to translating motion, M to V naught R. What is the axis? The axis is this one. This axis is passing through point P and perpendicular to plane. Finally, and what is the rotational motion? About center of mass. IC omega naught. Anti-clockwise, no? Try to look at here. So 2 mv naught R. Clockwise, let me take it. This is positive. Anti-clockwise negative. And it's a ring. Mr square by 2 omega naught. And numerically R omega, what you can write it as? Only it's a ring. I got positive. Positive in the sense. Finally, this is the initial, and we know that LPZI should be equal to LPZF. LPZF should be equal to LPZI. From where? Due to conservation of angular momentum, because net torque about axis passing through point P should be 0. I think everything is visible. Yeah. So therefore, what is initial angular momentum? We got it, mv naught r. So finally, what should happen to the rigid body? It should attain pure rolling with angular momentum clockwise. I think what I assumed is correct. What I assumed is correct. So what actually happens here? First, what will happen? This friction. So I'll finish off the problem. So final angular momentum plus IC omega mvr mr square. This is v by r for pure rolling. So finally, what happened? V is equal to v naught by 2. Can we calculate time taken to attain pure rolling? It's quite very easy. V naught minus mu gt. V naught by 2 equal to V naught minus mu gt. What is T is equal to V naught by 2 mu g. After this time, it will attain pure rolling. And now, what are the things which you have to really analyze here? Sir, how do you can say here it attained pure rolling? And you look at the previous problem. You say that it will come to rest. You have to look at the initial angular momentum. If initial angular momentum is 0, finally the rigid body will come to rest. If initial angular momentum is clockwise, then finally what happens? The rigid body will attain pure rolling in moving in the direction of initial velocity of center of mass. I'm making things clear. What is the direction of velocity of center of mass? Towards right. So in what direction the rigid body will attain pure rolling? Finally, it will attain pure rolling with velocity of center of mass in the direction of initial velocity of center of mass. Because the initial angular momentum, what we got, positive. So final angular momentum should also be positive, that clockwise what you should get. Say like finally say omega should be clockwise. Omega is anti-clockwise. So how do this directional change? First I should decrease this omega naught. Then what I should do? Then it becomes 0. Then it increases. Basic, all these are basics. Rotation motion, circular motion, we have done no, so many problems. So how the motion of the ring will be like this. Will be like this. Then angular velocity keep on decreases. At one instant will become 0. Then spin. So how it will? First it will have negative spin 0, then positive spin. Who will change the direction of friction? Who will change the direction of angle? The friction only. The friction, what it does? It will change the direction of omega. You see first. First it will decrease it. Omega 1 less than omega naught. Omega 3. First, next what will happen? Omega will be greater than omega 3. I think you should make observation of all. See, we have studied in circular motion. First it will rotate anti-clockwise, then afterwards it will rotate clockwise. Some equations, mathematical things we have done. That only what we can apply here. Do notice I'll have water. Okay, fine. So this is, I think, before entering the problem, what you should do, check what is the spin and linear velocity given. If LPZI, if it is clockwise in the direction of the translating initial angular momentum of translating motion, in that direction, the body will attain pure rolling. Okay, let's take the next condition. Try to see this. This again, it's a ring. You can do for any rigid body. I just picked up the ring. Look at the spin. The spin is given